So sorry I couldn't be here today. Wife got too sick, but I came in this morning to finish up the notes. So this is sixth period. They didn't get as far as everybody else. So most of y'all need to jump to, I think, slide 7. I think I got everybody through maybe 7. But anyways, for sixth period, you can start here because this is where we got off to. So we were talking about, we're adding in this horizontal compression, and we're going to compare something old, which by the way has a vertical compression. Oops. Oh no, what happened? Something happened. It crashed. Let's try this again. All right, so here we are. Anyways, I'm going to compare these two equations. This is a vertical compression to this location, which is actually a vertical stretch. Sorry, tired. Horizontal stretch. It's about location. Location determines what something does within a function. Well, apparently that's been done on this one. Okay, let me just reopen this lesson. This is making a liar out of me. Anyways, this is the old lesson. Graph 1/2 x minus 3 squared plus 4. Mom is going to be x squared. Mom contains 0, 0. I graded a couple of y'all's quizzes by now, and some of y'all don't know your mom functions. Shame on you. You need to hurry up and learn those things. Here's mom. She has a domain of negative infinity to infinity. She has a range from 0 to infinity. The kid's got a couple of basic transformations. We have a right 3. We have an up 4. And then we have this, which is a vertical compression or initial slope of 1/2. Sorry, vertical compression. What that's going to do is we're going to rise a half a block as we run one, and it's going to make this thing shorter. But you know, if you push down on some Play-Doh, in addition to making it shorter, it makes it wider. So hence, vertical compression and a horizontal stretch mean the same thing. So right 3, up 4 is going to put me about right here. And the initial slope is simply a half. And that makes this thing wider. So hopefully I got a little squiggly there. It shouldn't have. But that's a vertical compression. Domain is still going to be negative infinity to infinity. The range, the low y value is right there where y is 4. So 4 to infinity. And the goal here is not necessarily to confuse kids. The B term is rather difficult for a lot of kids to work with. So what we're going to do is we're going to turn it into an A term. That's what we're going to do. We have the same mama here. She's still x squared. There's a 2 there. There's an x. Same mom. Her domain is always negative to infinity. Her range is going to be 0 to infinity. And the transformation that's present here is this guy right here. That's a B term. And because it's inside, it's about the horizontal. Anything on the inside of parentheses is about horizontal. And it works opposite the way you want. Normally you see a half, you think half height. But if you're half the height and you push down on Play-Doh, you're going to be twice the width. And I didn't leave a place here for the transformation. But the transformation is a horizontal stretch. With a factor of 2. It's going to be twice as wide as mama. That's what it's going to be. It's going to be twice as wide as mama. Anyways, let's go ahead and start manipulating. There's a property. It's on your form quizzes, which you take next week. Talks about a times b to the x, and that is a to the x times b to the x. That property enables me to distribute these exponents. All right? So this equation becomes a half squared times x minus 3 squared. And I'm not going to worry about what x minus 3 squared is because then I wouldn't be in the form that I want to be. So if I take a 1 and squared, I get a 1. If I take a 2 and squared, I get a 4. And I have an equation that I can now work with. Because now I've gone from having a horizontal stretch to having an initial slope or vertical compression. And that's something we know how to work with because remember, this is definitely the initial slope. All right? So we still have the right 3 and up 4. That didn't change. But the initial slope is a quarter. So this one got a whole heck of a lot wider. Now, the domain didn't change. Still negative infinity. The range has a low y value of 4 and a high y value of infinity. So the goal here is simply to convert things. I think up next in your notes is probably absolute value. No, it's a cubic. So same property. By the way, let's do mom first. Mom is x cubed. Her domain is going to be negative infinity to infinity. Her range is going to be negative infinity to infinity. And x cubed is the one that's tall and skinny. See, it's going to pass through 2 negative 8, 2, and 2 positive 8. Mine ain't perfect. We're going to use again our property, a times b to the x is a to the x, b to the x. And we're going to distribute that 3. Now be thinking about what 2 cubed is. If you don't know that, it's not 6, it's 2 times 2 times 2, which is 8. And then we have x minus 1 cubed minus 4. It's a bad looking 3. Fix that. Cubed minus 4. We have a couple of transformations here. We have a right 1. We have a down 4. And the original transformation here, I need to talk about that. The original transformation was a horizontal compression. But it became a vertical stretch. Now, do remember that the big deal for graphing purposes was to think of this as initial slope. So let's do our shifting. Let's do orange. We're going to go right 1 and fall 4. Now we have a slope of 8, so we're going to rise 8. It's going to be negative 4 plus 4 is positive 4. And we're going to fall 8. Now negative 4 minus 8 is negative 12, which doesn't exist on this grid. So we'll just extend it a little bit. And we end up with this super skinny kid. It's a super skinny kid because if you think about the transformations I was telling you about, we had a horizontal compression, which means you push in on things from the side. And it became a vertical stretch, which means you pull on it from top to bottom. So hopefully you and me are on the same page and this isn't going to be so bad. Now this is absolute value. Absolute value, it just has like an understood 1 here. Like, so there's no point in distributing anything. All you got to do is take these two terms and multiply them together. It becomes negative 4 absolute values of x plus 4 minus 5. Now, mom is the absolute value of x. I graded a couple of quizzes where kids didn't know it. Shame on you. Just shame. That's all I can say. We spent 4 days getting up every day, beginning of class, going over these mom functions, and you couldn't graph a v? Like, are you kidding me, bro? Domain of that thing is going to be negative infinity to positive infinity. Range is going to be 0 to infinity. And this thing had a couple of transformations in the beginning. I really just want to focus on these two, but I'll go over all of them so you don't think you don't have to on your homework. We have a left 4 we have a down 5. And if we look at the way this thing is written, we have a horizontal compression is literally half the width. A 2 cuts you in half widthwise on the inside. And we have a vertical stretch, twice as tall. And then we have this negative symbol, which is a vertical reflection. And we do a little magic of mathematics, and it turns out that we can just say, hey, it's nothing more than a vertical stretch 4 times as tall and a reflection. Anyways, let's go ahead and graph this kid. Let's do pink. Maybe. All right. We've got to go left 4 and down 5. Puts me about right here. And the initial slope here, again, remember initial slope ideas. You guys need to let this stuff stick. Fall 4, you got to run both ways because you're trying to draw a V. Domain of that V is still going to be negative infinity to infinity. The range is going to be negative infinity all the way up to negative 5. Bracket on that negative 5 because you can put your pencil on it. And there you go. Easy peasy, lemon squeezy. All right, here we have that third power. So the third power is something you should have in your head by now, is nothing more than a cubic root. That's all it is. And you got this B term in here. Now let's talk about the transformations that are present in this thing. Right now, if you look at that negative 27, you have a couple of things going on. You have a horizontal compression, and it's a doozy. 1/27th the width. And you have a horizontal reflection. You have a horizontal reflection because there's a negative symbol in there. And then we look outside, and I see that I also have a vertical stretch. Twice as tall, which makes it even skinnier. And you have another negative symbol out front, which is a vertical reflection. And again, we're going to do some math, and we're just going to make it all disappear. All right? The cubic root of negative 27 is negative 3, because negative 3 times negative 3 times negative 3 is negative 27. That pink doesn't show up too well, does it? So we're going to do some math. We're going to make it disappear. Change over to a better color for you. Navy. Blue usually shows up pretty good. So if I take the cubic root of negative 27, I get a negative 3. I am not going to take the cubic root of x plus 3 because I have no idea what x is, so I can't. And now negative 2 times negative 3 is just 6. Math is about manipulation, kids. Manipulate it into something else you can work with. All right, so before I start graphing this thing, let's graph mom. Mom is not that. Mom is the cubic root of x, or x to the 1/3. You've got to be comfortable with both notations. And we do use exponential notation quite a bit. Cubic root of x has the key point 0, 0, 1, 1, negative 1, negative 1. She also passes through 8, 2, because the cubic root of 8 is 2. And she also passes through negative 8, negative 2, because the cubic root of negative 8 also happens to be negative 2. Anyways, there's mama. Her domain and range are the same, negative infinity to positive infinity. That's been said dozens of times by now. You just ain't been paying attention. And now we'll graph the child. The child is going to go up 1 and left 3. Up 1 and left 3. Should put me about right there. And the child has an initial slope of 6. Remember? initial slope. So we're going to rise 6, should take me to 7, and run 1. Conversely, we're going to fall 6 and run backwards 1. So the child got really tall, and it got really tall because it was horizontally compressed and vertically stretched. And the child's domain and range are still negative infinity to infinity. All right, 2 slides left to go. I would say if you have any questions, ask me, but this is a video, right? So nothing you can do. The mom function here is x to the 1/2 or square root x. Square root of 0 is 0. The square root of 1 is 1. Square root of 4 happens to be 2. That's a nice little point there. Helps you get more shape on it. Let's talk about the domain and range. Sorry, getting ahead of myself. Domain is 0 to infinity. Range is 0 to infinity. Remember, domain is x, 0 to infinity. Range is y, 0 to infinity. Some of y'all not grasping that. I don't know what's up with you. So again, we're talking about the square root function. So I'm just going to do that rewrite. 36 x plus 3 minus 4. Square root of 36 is 6, and there's already a negative symbol out front, so we're just going to leave it there. And before we look at this thing, go back and look at this thing and think about your transformations. There was a vertical reflection. I'm looking left to right now. Vertical reflection. Horizontal compression, 1/36 the width. Horizontal compression. One-36th width. And then, of course, we have the easy stuff, left 3, down 4. And we'll do everything with this guy because we'll just use this concept of initial slope. All right, so left 3, just do black. Left 3, down 4. Back 3, fall 4. Puts me about right there. And I have this slope of -6, which means I'm going to fall 6. -4 minus 6, last I checked, was -10. I'm pretty sure it is. And then right 1. And here is that super skinny, but also super tall kid. Her domain now, her low x values where x is -3. And then she runs right to infinity. And her low y value is -infinity, and she rises to -4. So there you go, kiddos. It's not that bad. It's really not. Last one, then you don't have to hear me talk unless you're going to watch the video of me doing homework. This one has some issues. The issue is the inside is not in the form x minus h. That's its issue. The forms you're learning are x minus 8, not 4x minus h, x minus h. So we're going to do just a teeny tiny tad bit of factoring. It's called factoring out a monomial. We're going to pull that 4 from both terms inside. And then we can kind of do that distributive property. All right. So there we go. The mom function is the absolute value of x. Mom's domain will be -infinity to infinity. Mom's range will be 0 to infinity. I'd say 2/3, 3/4 of you have that memorized. Good for you. It's that other 1/4 of you that needs to get your crap together. And mom contains 0, 0, 1, 1, -1, +1, and she is a friggin' V, kids. She's a V. Now, the transformations that were present, I would just go with this one on the bottom because we had to do a lot of manipulation to see transformations anyways. So the transformations that are present are simply right 1 up 3. It's vertical stretch, 8 times the height. And then we have this vertical reflection because we have a negative symbol out front. So let's graph the last one of the notes. We're going to go right 1 up 3, right 1 up 3. Our initial slope, again, that's what this dude is right here, is to fall 8. Should put me about right there, and run 1 both ways. And then we're going to draw that V. And there you go. Domain of any V is going to be negative infinity to infinity. And the range of this V is going to be negative infinity rising to a Y value of 3. So there's the end of the notes. I'm sure the sub has said what you're supposed to be doing after this, but I don't know if they have or not. So things to remember. You have a quiz tomorrow. I will be here tomorrow, unless my wife is still sick. So definitely do the review sheet. The sub has extras if you lost it. All right. You also have homework. You do. So work on that. All right. If you lost it, sub has it. If your 6th period sub has it, because you guys didn't get a copy of the homework last night, and most of the females in the 6th period had to leave for the math craft lab thing they were talking about. But you still have a quiz tomorrow. Just because I ain't here today doesn't change tomorrow. You still have homework. I'll go over it tomorrow after we take your quiz. Ain't nothing changed. Just because I'm not here doesn't mean you're not held accountable for things, kids. But I hope you had a good day. I hope this didn't take you too long. And I will see you on Friday. I will. Enjoy the remainder of your day.